Welcome back to the channel, everyone. Sorry it's taken me so long to get out another video. For those of you who are new, I'm Danny and this is Start Assemblies. In this video, I'll be sharing our current progress on my twin engine design. I will be talking about some of the cool features and sharing our projected aircraft speeds and weights. Be sure to stick around to the end of the video as I will be talking about one of the coolest features about this design, jet thrusters. Alright, let's get started. To start off with, what you've been viewing is the most recent photos of my design. In the last video, I talked about the background and development of this design. If you haven't seen that video, please check it out. There's a link down below. This video is part of an ongoing video series showing the progress of my design. I hope you will like what we're doing and want to follow along. For those of you who have already watched the two previous videos, you already know I chose to use a CAD program for my design, mainly because I saw a lot of advantages to using CAD. Using a CAD program will help a lot down the road once I begin selling kits of this design. Yes, I'm excited to tell you that my long-term plan is to sell kits once all the flight testing of the prototype has been completed and any needed changes have been made to the design. I know I will be manufacturing many parts that need to be cut on a CNC mill or 3D printed. To make these parts, it's best to do them in CAD first, then transfer the files to the CNC machine. Also, I need blueprints and drawings. I will need an assembly manual and a complete list of every part, every nut and bolt that needs to go into the kits. Using a CAD program will give me all of these abilities. Plus, once I'm done, I can hand my CAD files over to an engineering company and they can verify my design before I build the very first part. Several viewers have brought up that I should make a scaled down RC model of this design and test it before building the prototype. I have thought about this myself since I have a bit of experience in building and flying RC models. But honestly, I do not feel a scaled RC will help us to anticipate how the aircraft will handle. Let me show you what I mean. Have you ever seen a lawnmower fly? What about Superman? Of course, everyone knows Superman can fly. Anyways, my point is that things which can be done in the RC world cannot always be duplicated in the full scale world. Although Sean D. Tucker does a great job of trying. With that being said, there are several viewers that have told me they want to build a scaled version of my design once I have it finished. So, I will gladly give them some CAD files so they can build one. The one thing I do believe RC is good for is that it can show us the shape and scale of what the real aircraft will look like. Over the next year, I will be producing videos as we make progress to keep everyone up to date with the design. I wish I could make videos weekly, but with both my CAD guy and myself having full-time jobs, we're not making enough changes each week to warrant weekly videos. There are a lot of other things going on in my life right now that keep me busy as well. In about a year, when I retire from my job and go full-time with building the prototype, at that time, I'll be able to post videos more often. I'm looking forward to that time. During the construction phase, I am sure I will be able to post more videos. Those videos will probably be more interesting than what I'm doing now. Some may not find the tedious task of inputting the design all that interesting. But for those of you who do find the design process and the struggles we face interesting, thank you for taking the time to watch. For those of you who have offered positive feedback on the changes, a special thank you to you. So, as the title of this video suggests, I want to show you how we got from the very first CAD photos I saw that were made from the original drawings up to today. As a reminder, here are a few of the photos I got from my CAD guy back in February of 2020. After getting these photos, I was so blown away to finally see my mental concept brought to a photorealistic state. Now others could see what I had in my mind. Once I received these photos, we got to work. Lots of things needed to be changed. The first thing I wanted to change was the side profile curve of the nose. After that, I thought I wanted to change from the original round nose to a flat nose. The reason I changed it to a flat shape was because I started thinking about the stresses the pontoons would encounter in rough water on takeoff and landing. I wanted to make sure there was enough surface between the pontoons and the fuselage so that the flexing would not crack or tear them away from the fuselage. As we continued to make changes over the months, I went back to the original rounded nose. The reason for the change was because a couple of viewers felt the large flat surface on the bottom of the fuselage would, at low speeds and high angles of attack, create too much dynamic pressure on the bottom of the aircraft. Although I do agree that at low speeds and high angle of attack there would be a fair amount of dynamic pressure, I personally felt the aircraft had enough control surface area to manage this. Also, it can be a good thing as the pressure causes a type of lifting which will help us get off the water faster. The front opening between the water and the nose is larger than the back exit. This causes a high pressure area between the water and the bottom of the fuselage. So, at this point, I don't see it as an issue. Here is an example of an aircraft that has a massive flat bottom area, which is much larger than mine, and it flies fine from what I've seen and read. Once I have the design finished, then I will take a hard look at this and see if it is an issue. If so, then I will probably make slots along the sides between the fuselage and the pontoons for air to come out at low speeds. The second reason I went back to the rounded nose was because my composite guy has assured me that there will be enough strength between the pontoons and the fuselage. You may have also noticed the horizontal stabilizer, the elevator, the vertical stabilizer, the rudder, and the wings were all made longer. We also added the actual airfoil shape to the wings. At this time, we are planning on using the NACA 2415 airfoil with leading edge cuffs on the outboard sections of the wing. The wingspan is 45 feet from tip to tip. The area of the wing surface, which does not include the area of the flaps, ailerons, wingtips, is 161 square feet. The speed range I'm shooting for with a maximum gross weight of 3,500 pounds and using at this time two 120 horsepower engines is 140 knots with a stall speed of 45 knots VSO. One question a viewer asked me was, does this wing have dihedral? As you can see here, yes, it does have dihedral. Not much, but it does have some. Once the CAD files are run past the engineering team, they can let me know if we need more dihedral or not. The landing gear is obviously retractable and a completely new design. Although I'm fairly happy with the main gear, which is a trailing link design, the nose gear will be changed. Mainly, I do not like how the steering linkage connects to the top of the nose wheel strut. This and the control systems are two areas I'm always open to your ideas and inputs. I want the best design possible. So, if you have any ideas and you want to share them with me, please comment down below or drop me an email. My email address is in the description box below. During my initial design phase, I put 5-foot 10-inch men inside the aircraft to make sure the aircraft was to scale. In this photo, you can see what we changed it to. I don't have a before image, but the aircraft did have about 2 inches less headroom. I wanted to make sure a 6-foot 5-inch person would fit in the aircraft without any issues. Even with all these changes we have made so far, please understand, this is still very much a work in progress. There will be a lot of changes to this design between now and the time I build the prototype. I encourage input from all of you. If you see a safety related issue or want to offer an improvement idea, please let me know. Again, you can post a comment below. I do read and respond to all of your comments. With this channel still being small, I can easily stay up with all the comments people post. If you want to send me a private comment, just shoot me an email. Either way, I'm happy to hear what you have to say. One of the cool features I designed into this unique aircraft is electric water jet thrusters, like the kind you see on jet skis. These thrusters are just not as powerful and are smaller than the ones on the jet skis. So, there will not be any ugly water rudders on this sleek design. As you can see here, the jet thrusters are mounted in the rear of each pontoon. They will be controlled by a joystick located in the center console. This will allow the pilot to shut down the engines as they approach a dock or beach with people standing around and not endanger them with the propeller still spinning. The jet thrusters are like trolling motors to gently approach the dock or beach. These thrusters also have thrust vectoring and reverse, which is used for slowing down. They would not be used for backing the aircraft. At least this is my opinion for now. Once we get the aircraft in the water and try backing with both forward and aft max CG ranges, I do not know how things will go. Another neat feature of having thrusters on each pontoon would be that it allows you to spin the aircraft basically in one spot. I've already been asked if these thrusters would be used during takeoff. My first thought is no, but I have not completely ruled it out. I'm always thinking about safety, and if one of these jet thrusters failed while on takeoff, it might cause the aircraft to swerve. I see too many things that could go wrong trying to use them in conjunction with engine power during takeoff. But we'll take a look at this during our flight testing. At this time, I have not sourced the controller which would work between the joystick and the electric thrusters. If any of you viewing this video have experience in this field, man, I'd love to hear from you. Pontoons. So far this has been the biggest challenge I have been struggling with. So if there are any pontoon designers watching this who would like to help us out, I am interested in hearing what you have to say. These past few weeks I've been trying hard to find a pontoon designer. I'm coming up blank. Once we select a pontoon hull shape, then we need to know where to locate it both forward and aft of the CG. This may sound easy, but with the shape of the pontoon not being symmetrical front to back, it does take a bit of calculations. Plus, the location has to be calculated both with and without fuel and passengers. So far, I know we have the proper surface area of the pontoon in order to have proper buoyancy. What I'm still working on is the shape and location. Originally, I was going with a speedboat shape as I figured it would allow us to cut through the water faster. But then I got to thinking, this shape may be this way to help the boat stick to the water, and that's just the opposite of what we need. What we need is a planing hull to get the aircraft up and out of the water fast. Also, on landing, I don't want it to sink into the water like a knife's edge. So the shape of the pontoon has gone through a lot of changes this last year. Here's the most recent shape we have basically settled on. Engines. I get asked a lot about which engines I plan to use. As of right now, I am planning on using the 2010 through 2012 BMW R1200 RS motorcycle engine with a gearbox reduction drive. The reason I chose this engine originally was that it is light, air-cooled, fuel injection, produces 120 horsepower, and is fully counterbalanced. Of course, price is the biggest reason. Being that this is not a real aircraft engine, this is the only reason why I decided to make this aircraft a twin engine. I felt that it would be safer to have two, since these engines were not originally designed for aircraft. So this is how my design became a twin engine aircraft. What I would really like to put on this aircraft are two UL 520 IS 200 horsepower engines. These engines are fully FADEC controlled, fuel injected, and air cooled. They also come in both left and right propeller rotation versions. They do not require gear reduction, which is one less thing that can break. Hey, maybe the guys at UL are subscribers, and when we get to the point of building the prototype, they will reach out to us and work us a deal. One can only hope. Anyways, I'm sure as we get to the point of selling kits, we will have engine mounts available for your favorite engine. Interior. Because this aircraft will be on the water and there's a good chance of water and wet bathing suits getting in, we will be selecting materials that are waterproof and mold resistant. We have begun work on the instrument panel, as you see here, but this is still a work in progress. Depending on avionics the customer wants, we will probably have more than one panel design available. The first panel we will use is the Dynon Skyview displays with the autopilot option. Controls. I've not started on any of the control systems as of yet. We are planning on having standard controls with toe brakes and steering through the rudder pedals when the gear's down. The flaps will be electric with position sensors. The flaps will also be the Fowler design. Aircraft structures such as ribs, spars, end caps are all being input now. Almost all of the aircraft is made of composite materials, primarily carbon and fiberglass, but other more flexible composites will be used in areas like the pontoons to absorb impact. The bottom of the pontoons will have a removable stainless steel strip to protect it from sand, logs, rocks, and other debris. Where do we go from here? Well, the plan of action is as follows. Finish the aircraft design in Solidworks. Hire a full-time aeronautical engineer or a company to prove the design. Build the prototype, which will take us years. Spend many months testing the aircraft to FAA Part 23 certification standards. Modify and refine the design as necessary based on what we learn from the flight test data. Then, if needed, build a second prototype with all the changes to that aircraft. Then more flight testing of the second prototype to verify the design changes work correctly. Finally, we will offer the first 5 builders of the production kit the opportunity to build the aircraft in-house to allow us to create assembly videos and manuals. As you can tell, all of these steps will take us years to accomplish, so don't expect to see kits offered anytime soon. The process of making it right and safe takes time. Many of you have asked about the specifications of this aircraft. Until we have the design finished, I cannot give you fully accurate numbers. But what I can do is tell you what my expected goals are for this design. It is a 4-seat amphibious aircraft. It has 2 BMW 120 horsepower air-cooled engines with other engines optional. It is all composite construction. Basic empty weight is 1,800 to 2,000 pounds or less if possible. A maximum gross takeoff weight of 3,500 pounds. Minimum useful load of 1,500 pounds. A stall speed of 45 knots. Full flaps power off VSO. A cruise speed of 140 knots or more if possible. V&E speed around 200 knots. Fuel capacity of 90 gallons, which is located inside the fuselage, allowing for easy removal of the wings. This means with a useful load of 1,500 pounds, we could have full fuel for 200-pound people plus 100 pounds of bags and still be 30 pounds under maximum gross weight. Again, keep in mind that none of these numbers are set. We have goals only as a guideline. Actual numbers, of course, will vary. Some of the cool features of this design are twin hull amphibious aircraft for stability while on the water. Water jet thrusters in the pontoons for maneuvering instead of water rudders. Tricycle design landing gear. All glass avionic cockpit. A very wide cabin like a mid-sized car. a cabin ceiling height enough for a 6-foot 5-inch pilot, lightweight removable wings. There will be connection points on the back tail section for a hammock to lay in, and of course a very sleek design. Our current challenges are pontoons. As I mentioned before, at this point, this is the biggest challenge we have. I'm sure somebody will step up and help us with this. If not, we'll just have to hire an engineering firm to help us with it, or do it by trial and error. Time. With my CAD guy and I both working full time and having other things going on in our life, it is a challenge to find time for both of us to work on this project. I've been asked many times already, how much will the kits cost? Trust me when I say, I'm going to do everything I can to keep the costs down. This is why I'm looking at as many off-the-shelf parts as I can instead of tooling new parts. I am sure my twin-engine 4-seat aircraft will cost less than the Icon A5 and less than a new Cessna 172. The way I plan on calculating the cost of the kits would be what it costs me to make the kits, parts and labor, and then adding a 25% markup. This percentage will allow us to have a full-time builder support person, office workers, a factory for manufacturing, and continue to develop my second aircraft, which is a STOL design. And this brings us to money. To make an airplane fly, it doesn't take aerodynamics, it takes money. Or at least this is the way the joke goes. But for those of you who have owned an aircraft, you know it does take money. For me, this is a labor of love. I do this project because I love the challenge. I want a very unique amphibious aircraft, and I want to give back to the flying community. As of right now, we have next to no out-of-pocket cash in this design. I plan to keep it that way for as long as I can. As I mentioned, this is a labor of love and not a for-profit venture. If profit comes later on, then those who have joined me now will enjoy the rewards. When we begin purchasing parts and supplies for the prototype, that's when money will be invested. Right now, we're not looking for investors. I have seen too many companies with great aircraft designs go out of business because the investors they brought on focused more on the return of their investment than getting a product to market. I will do it the other way around so that I have complete control of the design and building of the prototype. Once I have a marketable product, then I will be open to investors coming on board to get the full-scale production plant up and running. Those of you who wish to support this project and videos, there's a link down below. I would like to thank all of you who have already donated. Every bit helps. Well, thanks for watching. I'll see you on the next video.